and in the tropics. I mean, obviously, for us as an international business building in many markets, I think it's very important to localize the solution. You know, we're not building this necessarily the same way that you would build in Geneva or even in Brisbane. You know, we come up with solutions, and I think it's very important to come up with solutions that are very locally relevant. So, you know, you rely on concrete and steel where it works best, use the timber where it works best, and, you know, come up with a hybrid solution that is very much in tone with not just the physical climate, but also the macroeconomic climate, and of course the development aspirations of the country and or the developer. The main difference, the physical difference in terms of actually constructing these buildings, is in those days we could kind of figure out what we needed, order a whole bunch of material would turn up on site, then we'd put together a team of really sort of competent craftsmen, so, you know, and use their expertise to interpret the drawings and essentially build it on site. Whereas these days, we've done all that work on the computer. You know, we've engineered it and modeled it in software, we've virtually built the building, you know, on the desktop, and then sent all that information to machines, you know, on the other side of the world that have put all that code together and have basically produced precise components. So when those components arrive here, it's the complete opposite, because now we use a well-trained team of installers. They're not craftsmen, you know, they're just basically well-trained installers to put together all these components in a sort of Meccano Lego type way to assemble these buildings much, much faster than we did in the past, with far fewer people. I would argue much safer, because everything is predictable. And you know, so it's a huge contrast over the last 25 years. This is the only material that actually arrives on site negative. Yeah. You know, it's negative. And I think a lot of people don't really understand the impact of that. If this was built in steel and concrete, it would have produced 5 times more carbon than its offset. So the difference is between what it could have been and what it is now, being negative. So I think that's a concept that we're always trying to get in front of customers and the public. People don't just believe labels, they want to see proper audit processes that PEFC brings. They want to see visibility where these products are from. It's a premium building solution, and I think you need to make sure that there's real value in the sustainability. There's a real story that people really understand and appreciate. Of course, first and foremost, we're building with a very productive and sustainable material. Sure. The source of the product is everything, you know, so of course the PEFC, and being proud to be the first PEFC COC holder, you know, we're treating the forest the same way we would tend to our garden. We're thinning it out. We're taking those trees that can be removed sustainably and be replaced, and then we're turning it into a 50-year building material. So, you know, I think in terms of the built environment, it's quite a transformative solution. It's just, we just hope that there's more uptake and more enthusiasm in building this way.
That's right.
So tell me how this compares with some of your other projects that you've done in Singapore. How different is it?
I mean, obviously, when we look at the building, the level of complexity is unbelievable. I mean, what is interesting with this type of building is that, you know, we spend a lot of time in Singapore talking about productivity, talking about design for manufacture and assembly, which is basically how to rationalize the building process so that there can be more use of, say, connections and components and so on. But sometimes, you know, there's buildings that don't fit in that genre, you know, and you look at this building, it couldn't be any more unique.
Yeah.
I don't think there's another building in the world that looks the same as this.
Right.
So, you know, when you're making those sorts of statements, then I think it's really important that the material can work in a way that can create unique forms. So, you know, one of the key attributes of mass engineered timbers, of course, primarily it's very sustainable and it's productive. but it does have the ability to be able to build very unique forms.
Sure.
And you know, although a lot of engineering challenges, of course, we're looking at off-axis and cantilevers and all sorts of techniques to brace, special concealed connections and so forth. But the way that timber works, it's quite an intuitive material. And even when we take a building of this complexity, you know, timber is still a great choice.
Yeah.
Particularly as, you know, remember these days we work a lot in 3D.
Right.
Can you imagine building this building
Without
3D?
That's right.
You would have a shock of your life. So, you know, and again, because timber works so well with the BIM, with 3D modeling,
Yeah.
and that modeling process eventually drives machines in the factory. You know, it works great for these kinds of buildings, but, you know, would it necessarily be the best choice for something more generic? You know, I don't know. But I think certainly with this kind of unique building, I don't think you can think of any other product that would really do the job like timber. So that's great. This building was called on a performance basis. So it was very much up to the specialist and the specialist engineers and the manufacturers of certain components to come up with the best solution. Quite often we see there's two ways of building these buildings. There's that performance-based where the specialists get together and they draw on all their knowledge and they create the best scheme. But another approach is when an engineer comes up with a solution on his own, which can be largely theoretical. So this is a prime, I would say, example of where that confluence of knowledge from different fields, from practicality of building, which is us, the experience of engineers on previous jobs, and obviously the partners who have to produce products and machine products and create products. So I think that is the really important process, especially in a job of this complexity. In terms of time, obviously early engagement is everything.
Sure.
I mean, you can't imagine how many U-turns that they went through in terms of coming up with the right geometry, the right connection strategy. In fact, if we look at the top here, we'll see there's a connection where those two main members come together. You'll see here. Now that's using a new type of connection, which is called the glued-in rod. So we've actually pioneered that in Singapore, and we've had to do full-scale testing to prove it. So, you know, there's been a great deal of preparation that's gone into to making this work. Yeah.